Hello everyone. So today's video I'm going to explain chemical equations, how to balance the chemical equations. So chemical equation balancing is a trial and error method. So you need to add coefficients, or we call numbers, behind each chemical species to balance each type of atoms in reactant sides and the product sides. The concept here is the law of conservation of mass. What is the law of conservation of mass? So the law of conservation of mass states that the mass or the atoms cannot be created or destroyed. Therefore, number of atoms in the reactant side should be equal to the number of the same type of atoms in the product side. To equalize a number of each type of atoms, we are adding numbers. So these numbers we can start from smallest positive integers to the largest, and then try to balance each type of atoms in both sides. This is trial and error. However, when you are balancing the hydrocarbon combustion reaction, there is a specific pattern, but for all the other reactions, it's a trial and error. So these are few examples. Let's try how to balance the chemical equations in one by one. Reaction 1. This is potassium chlorate. Potassium chlorate is a chemical we used to produce oxygen in the laboratory scale. So if we heat potassium chlorate with a small amount of manganese dioxide as a catalyst, we can generate oxygen. So let's see how we can balance this equation. Potassium, chlorine and oxygen are the three atoms in the reactant side. So let's balance one potassium reactant side and one potassium in the product side. This should be Cl, KCl. And one chlorine. So potassium and chlorines are balanced in both sides, 1, 1. 3 oxygens here, but 2 oxygen in the product side. So the common factor to 3 and 2 is 6. So let's make 6 oxygen in each side. So how to make 6 oxygens here? Multiplied by 3. So we added coefficient 3 for the oxygen. Then 3 times 2 is 6. 6 oxygen atoms now in the product side. But still reactant side only 3 oxygen atoms. So let's add the coefficient 2 to give 6 oxygen atoms. So 2 times 3 is 6 oxygens. 3 times 2 is 6 oxygen. Now oxygen atoms balance. Now potassium become 2, chlorines 2. Potassium and chlorine now 2 atoms in each in the reactant side. So we need to add coefficient 2 to balance the potassium and chlorine in the product side. Now reaction is balanced. All potassium, chlorine and oxygen atoms are balanced with the product side. Let's move to second reaction. Second reaction, when iron react with oxygen, make iron 3 oxide, or another name is ferric oxide. So iron 3 oxide, we all know it is we call iron rust. If we place piece of iron outside 1 or 2 days, so we can see brown color rust formation. That iron rust is the formation of this compound, iron 3 oxide or ferric oxide. Now let's see how we can balance this equation. Again, like equation 1, oxygen 2 atoms in the reactant side, 3 oxygens in the product side. So even and the odd number. So let's make the least common factor to 2 and 3, that is 6. First I am going to multiply it by this side by 2. Then I can make 6 oxygen in the product side. 2 times 3 is 6. 6 oxygen atoms. So how we can make 6 here? Multiplied by 3. 3 times 2 is 6 oxygen. So oxygen balance right now. The only thing remaining is iron. So 2 times 2, there are 4 Fe atoms, 4 iron atoms in the product side. 2 times 2. So then I have to add 4, the coefficient 4, to balance the Fe. Let's go to our third reaction. Third reaction is water is in liquid form and it decomposed into H2 and oxygen gas, hydrogen and oxygen gas. So let's see how we can balance this equation. So there are two hydrogens, hydrogen already balanced, but one oxygen here, two oxygens in the product side. So I'm going to balance oxygen first, adding coefficient 2. Now 2 times this is 1, 2 oxygen atoms in the reactant side. Now 2 oxygen atoms, O2, 2 O atoms in the product side, oxygen balance. How about hydrogen? 2 times 2, 4 H atoms, 4 hydrogen atoms in the reactant side. So I will add coefficient 2, then 2 times 2, 4. That's how the reaction is balanced. Next reaction. This reaction, potassium iodide, when react with lead nitrate, it form very bright color lead iodide. It is a yellow color solid. Another name for the solid we call precipitate. Precipitate over solid plus potassium nitrate. Now how we can balance this type of reaction? Earlier we discussed polyatomic anions. Polyatomic anion meaning is poly means many atoms containing anions like sulfate, nitrate, nitrite. Those are many atoms containing anions. So here nitrate, polyatomic anion is present. So if you have any polyatomic anions like nitrate, sulfate, chlorate, acetate, you have to consider that polyanion as a one unit. For example, there are two nitrate groups. The whole thing you have to consider as one. So how many nitrate groups here? 2 nitrate groups. So in the product side, only one nitrate groups, NO3 groups. So then we need to add coefficient 2 to balance the nitrate groups first. 2 nitrates and 2 nitrates. Now let's balance potassium. 2 potassium in the product side, 1 potassium in the reactant side. And 2 iodine is here, product side, 1 iodine in the reactant side. So if we add coefficient 2, we can balance both potassium and iodine. Nitrate we already balanced. And lead atoms, 1 lead atom in the reactant side and 1 lead atom in the product side. So everything balanced in this equation. The important point here is when you are balancing chemical equation with polyatomic ions, you need to consider polyatomic anions and cations as a whole unit. So if you break this polyanion, how many nitrogens and how many oxygens, then it will be very hard to balance. So consider this whole thing as a one unit. How many nitrate groups, how many sulfate groups. Right? Next one. So it is kind of different. Hydrocarbon combustion reaction. So what is the meaning of combustion? Combustion meaning is hydrocarbon, or sometimes it contains oxygen too, when combined with oxygen to form carbon dioxide and water. So these type of reactions we call combustion reactions. So not like other reactions we discussed, combustion reaction there is a specific pattern we need to balance. So if you follow that specific pattern, that is easy to balance this chemical equation. Let's see what is the pattern. First thing is you need to focus on carbons, and secondly you need to focus on hydrogen. At last you need to focus on oxygen. Carbon, hydrogen, oxygen is the the order you need to focus on when you are balancing the number of atoms. So let's focus carbon. There are 7 carbon atoms in the reactant side. Product side only 1 carbon. So I'm adding coefficient 7 to balance the carbon. Now carbon 7 carbons here, it's balanced. Next we'll focus on oxygen. There are 16 oxygen in the reactant, hydrogen in the reactant side, but only 2 here. So how we can make 16? I multiplied this by coefficient 8. Now 8 times 2 is 16. So hydrogen balance. At last, finally, let's focus on oxygen. 2 oxygen in the reactant side. Now how many total oxygen in the product side? 7 times 2. 7 multiplied by 2, 14. Plus this 8 multiplied by 1 is 8. The 14 plus 8 is 22. There are 22 oxygens total in the product side. Then how we can make 22 here? So if we add coefficient 11, 11 times 2 is 22. Now oxygen we can balance. The important point here is in hydrocarbon combustion reaction, not like other chemical reaction, it is kind of trial and error. However, first you need to focus on carbon, then hydrogen, and at last oxygen. Right? Let's move on to another one. Next reaction is FeBr3 react with sulfuric acid to form iron 3 sulfate and HBr. Right? Now let's see, this is again a polyatomic anion, sulfate. So how many sulfate groups? 1 here. And in the product side, 3 sulfate groups. So then let's add 3, the coefficient 3 here. Now 3 sulfate groups, SO4 groups in the reactant side and 3 SO4 groups in the product side, sulfate balance. Now let's see how we can balance hydrogen. There are 6 hydrogens, 3 times 2. 6 hydrogens already here. And 2 Fe atoms in the product side, 1 Fe is in the reactant side. So if we balance iron first, I will add coefficient 2 here. Now Fe2 atoms in the reactant side, Fe2 atoms in the product side is balanced. Sulfate balance. The last thing is hydrogen and bromine. So bromine 2 times 3, 6. So how we can make 6? Coefficient 6 I added to HBr. So 6 hydrogens, 3 times 2, 6, it is balanced. And 2 times 3, 6 bromine atoms in the reactant side and 6 bromine is here. So that reaction is balanced now. Now let's move on to our last reaction. This one is again a combustion reaction. C3H8 we called propane. Propane combustion reaction when joined with oxygen it produces carbon dioxide gas and water vapor. Again the same method we need to apply when hydrocarbon combustion reaction balancing. First thing we need to focus on carbon, second hydrogen, and then finally oxygen. So there are 3 carbon atoms, so I will add coefficient 3. Carbon balance. Next hydrogen, 8 hydrogen atoms. So I need to make 8 here. So I multiplied this by 4, coefficient 2. Now 4 times 2 is 8, hydrogen balance. Finally, let's focus on oxygen. 2 oxygen in the reactant side. Product side, 3 times 2, 6 plus 4. Total is 10 oxygen atoms in the product side. So how we can make 10 here? Adding coefficient 5. Then 5 times 2 is 10. The reaction is balanced. I hope you all understand now how to balance the chemical equations. It's totally trial and error method. But in the hydrocarbon combustion reactions, you need to focus on carbons and next hydrogens and finally oxygen. And the concept here is the law of conservation of mass. The number of each type of atoms in the reactant side you need to balance with number of each type of atoms in the product side. Thank you all for watching.